Hello friends, welcome back to Core Java Tutorials. I am Sudha and today let us walk through the advantages and disadvantages of multithreading. What is a process? A program under execution is called as a process. Process is also called as heavyweight as it uses lot of resources for its completion. A process has its own address space. Each and every process has its own memory space which it uses to store the instructions being run, as well as any data that it needs to store and access to execute. Each and every process will have its own address space, and processes do not share the address space among them. So here you can see like CPU is executing four processes. Like what is a process? Like it can be an editor in which you are writing a Java program. So it can be a process. At the same time, you want to listen to a song. So you opened an MP3 player. Okay, and at the same time, like you're downloading something or you're uploading something. All these are processes that are executing simultaneously and independently of each other. Okay, so each and every process is having its own address space, and they do not share the address space, and they execute independently and simultaneously. So that's called as a process. Now we'll see what is a thread. A thread is a single sequential flow of execution within a program. So herein you have to say single sequential flow of execution, and which is not dependent. Okay, so which should be independent. And a thread is a subset of process. So there can be many threads inside a process. And thread is considered as lightweight because it uses less resources than process. And threads share the address space of the process, but process have their own address space. Like the threads of the same process share the address space, okay, of the process, but process have their own address space. And a process can have single thread or multiple threads in it. So you can see a program under execution is a program under execution is a process. So a process can have single thread or multiple threads. And herein you can see a single threaded program. So for example, like JVM creates a thread whose task is to define the main thread. JVM starts the thread and the thread executes the statement of the program one by one, and after executing all the statements and method and executing all the statements, the method returns and the thread dies. Okay, so this is called as an application thread. And what is multi-threading? Okay, so multi-threading is the ability of the CPU to provide multiple threads of execution concurrently supported by the operating system. Or the simple definition is a process of executing multiple threads simultaneously is called as multi-threading. Okay, so examples of multi-threading. So word processor, like word processor, like typing in a word processor while it at the same time, like while you type in the word processor, what happens is like auto save happens, and also spell check happens, or taking input, that is responding to keys happen. So all these happen simultaneously. Okay, so all these are saving, spell checking, taking input, all these are threads like in the process which is word processor. And so browser, each tab is a thread. Like if you open Chrome, like each tab is a thread. Any GUI toolkit, like for example Swing or JavaFX, uses threads to keep track of events generating from various components. And computer games are very good example of multi-threading. Multiple objects in the game like cars, maybe human beings or animals, etc., are threads that run in the game application. Based on the nature of the task, we have to switch between multi-threading and multiprocessing. Okay, say for example, if there are heavy CPU computations, multiprocessing is needed. And if there are not much CPU computations are there, then multi-threading is preferred. Advantages of multi-threading: the main advantage is maximum utilization of CPU, then decreased cost of maintenance, and time saving, improves the performance of complex applications because there are parallel tasks. And multi-threading enhances data sharing with high speed, increases the server response rate, and increases the responsiveness of the program. So these are all the advantages of multi-threading. The disadvantages of multi-threading are complex debugging and testing process, and increased difficulty level in writing programs, unpredictable results, and thread scheduling. So issues occur in every software application, but what makes multi-threading such a great pain is that issues are hard to debug in multi-threading, okay, just because of race conditions. And due to the nature of asynchronous tasks in multi-threading, it is very difficult to understand the flow of application. So that's why the difficulty level in writing programs is more. And unpredictable results, okay, so multi-threading applications are worst in this. So because of critical sections, locks, thread pools, semaphores, mutable data structures, etc., the probability rate is very high. Okay. The other disadvantages are deadlock and starvation. Deadlock is a situation where both the threads hold the lock and they don't release their own locks but wait for the other threads to release the locks. And starvation is a situation wherein the thread is on wait for CPU cycles indefinitely. Somehow the thread scheduler does not execute a thread. These are the advantages and disadvantages of threads, my friends. Hope you like this video. Thank you. Bye.